Let's begin. Today's July 7th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 4, 5, 9, 16, 19, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C, and on the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our middle digit, the square digit, and we'll be comparing it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should it be greater than 4? Criteria card B looks at our first digit, the triangle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card C looks at the 3-digit solution, and the Turing machine will let us know how many of those digits should be 3. Should there be no 3s? Should there be a single 3, perhaps 2, or maybe even all 3 are 3? Criteria card D again looks at our 3-digit solution, and the Turing machine will let us know a little bit about the ratio of even to odds. So should there be more even than odds, or should there be less even than odds? Criteria card E will take a look at the first 2 digits, triangle and square, and we'll add those digits together, and we'll then compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F, again, will look at our 3-digit solution and will let us know a little bit about its structure, so to speak. It will let us know whether there might be a pair of digits in the solution, as in the example 131, or alternatively, there are no pairs and there are a couple of scenarios. Either all digits are distinct or different, as in the example 134, or all digits are the same, as in the example 222, where there's a single digit repeated 3 times. Remember, the objective of the puzzle is to find this one unique solution that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is whether that first digit is an even or an odd. So let me go ahead and test criteria card B. Okay, so the Turing machine approves of my proposal. Notice that I did choose an odd 3. So the Turing machine is just confirming that it's an odd. Not necessarily 3, but it is odd nonetheless. So let me go ahead and type in my notes in section B that triangle is an odd digit, and since it's odd, let me go ahead and cross out the evens. So let me cross out 2 and 4. Okay. Next, I think I'll test criteria card D to see, a little bit about the ratio of even to odds. So let me go ahead and test criteria card D. Okay, so it does not approve of my proposal. Notice that in my proposal of 314, I do have 2 odds to a single even. The Turing machine does not agree with the majority being odd. So that means that, in fact, even should be greater than odd. And that's what I'll type in section D. That there should be more even than odd digits. Okay? And then finally, I think for this round, I will test criteria card F. Okay, so it does not agree with my proposal. Notice that in my proposal of 314, I do have all distinct digits, meaning there is no pair, but the Turing machine does not approve of that. So in fact, there should be a pair of digits. So in section F, I'll say that there is a pair, and specifically an even pair pair of digits. And an odd. Okay, remember we do have more evens than odds. Oh, let me hold on. Well, there are more even than odds. In fact, I don't know if that last digit is an odd, because it could be that there's two evens and an odd, or potentially even all of them are even and just one of them is paired up. So let me correct myself. Let me just say that there is an even pair of digits. I don't think we've actually established that that third digit is odd, or, well, actually, no, in fact, it is odd. It has to be triangle. Okay, well, there we go. So let me go back and an odd, and we know it's triangle. So that means that we know square and circle to be even, right? That's our pair. And so let me go ahead and cross out all of the odds for square and circle. And so that kind of gives us the sort of structure of odd, even, even. And of course, again, square and circle must be equal. Okay, so that does it for this turn. We've completed our 3 Turing tests. We're now moving into the phase where we're going to be talking about how to construct a good second round proposal. Okay, so we did test criteria card A, which tells us a little bit about the square digit. And right there we know it's either going to be equal to 4 or less than 4, since it is an even digit. And criteria card C, well, of the odd digits that are available for triangle, it's either going to be a 3 or not, as far as criteria card C is concerned. And then finally, something about the sum of the first 2 digits. That's criteria card E. So what could that mean? So somehow we want to, typically the way this works is that 2 digits for triangle will kind of work for the sum, and it's either going to be the 3 or not. So if it's, say, 3, 5, to guarantee that, I believe it should be probably the sum is greater than 6. That 3 and 5 would guarantee. With a 4, in fact, that should be greater. If I want it to be less than, I would choose 2 for square, and then 1 and 3 for triangle. And again, that would resolve in combination with criteria card C, which of the 2 digits, 1 or 3 for triangle. And so let's see. And of course, you know, circle is going to default to whatever square is. So we're really, let's see, is there a way to deduce some of this information? Just trying to see, playing all the combination of possibilities for criteria card A, C, and E. What would work? Is there anything that we can sort of deduce or eliminate? Let's see. Can we even say that the sum is 6? At least we can eliminate the sum is 6 for criteria card E, since we are dealing with an even and an odd. So there's no way you can get a sum of 6 when you're adding an even and odd. So we know it's got to be, you know, less than 6 or greater than 6. And again, So somehow also, not only the 3, but trying to figure out what square should be. None of these cards are trivial. They all sort of put the whole puzzle together. So I'm trying to think of what could be possible. Because once you establish that square is 4, well, I guess it could technically be less than 6, right? Triangle 1 plus square 4 does give you a sum that's less than. And similarly, with square being 2, I guess you could potentially have something greater than 6 with a triangle 5, but you could also have something less than 6 with a 3. So it looks like almost, 3 is necessary to sort of split up the sums. So I will include 3 for triangle, and the sum is, I think at this point, it may be, well, let's see, if it's 3, yeah, if it's 3, it could either be the sum is less than or greater than. But then, wouldn't that just make square not redundant, because we also need it? That's very interesting. Or perhaps then maybe it's not a 3. Well, if it's the extreme of a 5, those are both greater than. Yeah, because I guess technically triangle 3 and square 4 does give you a sum that's greater than, but maybe we want one without a 3. So I think, yeah, we're looking at maybe the extremes, meaning triangle 1 and square 5. Yeah, so let's go ahead and do that. So I'm going to say, I'll say 522. Yeah, I think that's a good option. So let's do 522 and see where that takes us. Okay, so now I guess let's see, what would out of A, C, and E, is there an order that sort of helps us maybe deduce one over the other? I think we may be able to deduce the 3. So I think I'll test A and E. And so I think the first thing is, let me test the sum. So let me test criteria card E. Uh-oh. I accidentally hit D. Oh no. That's not going to be good for the Turing machine. Okay, so the sum is not greater than 6. Notice that I did choose triangle 5 and square 2. So the sum, I'm going to deduce that the sum is actually less than 6. So let me go ahead and type that up. And that was for criteria E. So I'm going to say triangle, or actually let me do this. I'm going to deduce that triangle plus square is less than 6. Okay. And so because it is less than 6, that means it cannot, triangle cannot be a 5, because 5 plus the remaining evens are all greater. So it can't be 5. 3 is still viable, and obviously so is 1. And anything else? Okay, so let's see. And of course, specifically looking at square, yeah, there are options with square 2. Both of them work. And 4 only works with 1. So can we deduce? Let's see, what if I chose 3? Oh, you know what? If I chose now criteria card C, if I know if it's a 3 or not, oh, but what if it's not and then it's a 1? Yeah, because, yeah, we should be able to use criteria card A to distinguish between 1, 2, and 1, 4. So if I know what square is, let's see, is there a way to deduce? I'm trying to think if I can get away with just testing one or the other. Yeah, it would almost seem that triangle has to be a 1, so that square is not irrelevant. But am I just saying that? Because if I know what 3 is, or meaning if I know that there is a 3, then I know it should be 3, 2, 2, and not 3, 4, 4. So yeah, let me go ahead and test criteria card A. Okay, so it is a 2, and so let me go ahead and type that up as square should be less than 4, and that was for A. So square should be less than 4, and so yeah, so that means that it's not 4 for square, and neither is circle. And so we're now down to either 1, 2, 2 or 3, 2, 2. And as I stated, I almost want to go with 1, 2, 2. But would that be accurate? I'm just gonna risk it. I truly do believe it's 1, 2, 2. But oh, and I do have to go to another round. Oh, how unfortunate. Yeah, that accidental D really ruined it. Okay, well, let me go ahead and go with 1, 2, 2, and let's do criteria card C. Gotta be careful, and type C. Yes, of course it was 1, 2, 2, as I, thought, but I didn't want to take a chance. And so again, for C, that means that it's true that there is no 3-digit. So I'll just type that up. There is no 3-digit. So that means that, yeah, the solution is 1, 2, 2. And we'll see how that affects the Turing Machine result or comparison, because it should have really only taken me 6, maybe even 5, had I, convinced myself of the logical choice of 1, 2, 2. Okay, well, let's go to turingmachine.info and verify the solution of 1, 2, 2. So 1, 2, 2. Yes, okay, fantastic. But here's the true test. How did we do? I'm afraid that the Turing Machine probably did it in 6, using 6 questions. All right, so we did BDE in the first round, and then ADE. I'm sorry, BDF, and then ADE. BDF and ADE. So B, D, F, and then A, D, I believe that was correct, A, D, E. And then third round, we confirmed that it was C. Let's see. Wow, saved. The Turing Machine also did it in 7 questions. Obviously, mine was accidental, right? I had already established that that D, we had more even than odds. So second round, D was accidental, but such is life. And so sometimes that will happen. At least, when I play, I'm not sure. I think even if you play the original Turing Machine Puzzle, when you're using all the punch cards, you could accidentally maybe choose the wrong criteria card for whatever reason, truly accidental or maybe just a slip of the mind. So stuff happens, but in this case, we still came out with a success. Well, that's it for today. If you did notice anything else that you'd like to comment on, please do so. And if you like the video, please give it a thumbs up. And if you don't want to miss out on any future videos, please do hit subscribe to be notified. Well, until next time, have a great one.